Hi, I'm Nathan Frost, a staff engineer for Qualcomm Technologies. Today I'll show you how you can use the Qualcomm 3D Audio plugin for Unity, a binaural spatial audio plugin for creating immersive XR, AR, and VR experiences in games. The plugin is designed to integrate smoothly into Unity projects to provide superior performance on Qualcomm Snapdragon-powered devices. It's ideal for easily adding lifelike audio to lifelike video playing in VR headsets, so that sound objects follow users the way they do in the real world. The plugin supports up to 64 spatialized sound objects, so you can create sounds emanating from point positions within an XR environment. Now let's get started. After you've installed the 3D Audio plugin, here's how the plugin audio features are exposed in Unity's interface. To create a sound object, attach a Q3D audio source script to each game object that has a spatialized audio source with a mono audio clip. The Q3D audio source script automatically inherits many of the properties of the audio source. You will achieve higher quality spatialization by directly rendering each sound object from its location, rather than interpolating the object's location between a discrete number of virtual speakers like many other spatializers. The plugin also supports two ambisonic sound fields. Creating a sound field is as simple as attaching a Q3D audio source script to an audio source that uses an ambisonic audio clip. Sound fields are an efficient way to create complex soundscapes that are always centered on the user's head, but respond to head rotation. This can be useful for external ambiances like an underground cave or underwater environment. Finally, the plugin also supports one shoebox reverb effect. This reverb is implemented in Unity by adding a Q3D audio room script to any game object with an audio reverb zone. The Q3D audio room automatically inherits its position and spherical radii and, like regular audio reverb zones, activates the shoebox reverb effect when the listener enters the sphere and deactivates it when the listener leaves the sphere. The shoebox reverb effect can be customized to a box of almost any dimensions. You can assign different sound reflection characteristics to the ceiling, floor, and walls of the box, and tweak several additional reverb parameters to achieve the desired effect. An added plugin benefit is that on supported Qualcomm Snapdragon-powered devices, you can offload reverb processing from the CPU to the digital signal processor, or DSP, to reduce power consumption. This is advisable if you're not using many more than about 32 sound objects, since you'll conserve battery power. To demonstrate this, we'll use Snapdragon Profiler. It's fairly seamless to switch between CPU and DSP processing, so you can compare the energy savings for yourself. The plugin is easy to switch off and consumes virtually zero resources when switched off or on unsupported platforms, so there's no need to create a separate version of your project for the Android platform. Any number of mono, spatialized audio sources in an existing project can be automatically converted to Q3D audio source sound objects. Similar functionality exists for converting audio reverb zones to Q3D audio rooms. These tools let you spend less time clicking and more time developing. You can request the 3D Audio plugin for Unity through Qualcomm Developer Network. You can also refer to the Quick Start guide on QDN to learn more about this product. We hope you enjoy using the Qualcomm 3D Audio plugin for Unity to bring a whole new level of sound immersion to XR users' ears.